Okay, so we're about to look at matching fk to ik, and in principle this will be almost identical to the method used back in Technical Rigging 3, and because of that we're actually not going to cover this in any great detail. However, now that we know that our character is going to become part of an asset, there's actually an additional consideration that we need to make. So to demonstrate exactly why we need to make that consideration, I'm going to create a new scene file. Before I do that, I do want to make sure that I save the existing scene file. Then we create a new scene file. Let's bring up our grid, home up on the view. I'm going to create a 2-bone chain with inverse kinematics. And if you recall, since we want to match fk to ik, we want to grab the ik rotations that are being created by the inverse kin chop, and in order to do that, we need to reference the channel name. And we can see that the channel name comes in with the bone name, colon, whatever the rotational parameter happens to be. So we have L underscore bone 1 colon rx through L underscore bone 2 colon rz. That's all very well, but that only actually happens when our bones exist inside /obj. If we were to grab all of these guys with Control A, Shift C to collapse them down into a subnet, and jump back inside, if I now middle click on our inverse kin chop, you can see the names are now subnet 1 / and whatever they used to be. The path from OBJ to that bone is included in the channel name. That's all very well in terms of a network we construct. We'd know where everything exists. But we don't know where an artist is going to be placing an asset. They could place it inside any part of a network. And that means we don't know what this value is going to be. So we have two different ways we can approach this. One, when we reference this parameter, we can go ahead and work out where is our bone in terms of an absolute path to our bone, and from there work out what is the channel name. Or we could turn around and actually rename the channels down inside the chop network to something that is predictable and the same time and time again. Now that's going to be the approach that I take here. Now with something simple like this, 6 channels that we know the names of, it would be very easy to go in, and with a rename chop we could simply go in and manually enter the names that we want to rename these to. However, I'm going to design a Python expression that's going to rename these as opposed to manually entering the names that we want. And that's going to create something that's a lot more versatile. It will work in any situation. We can copy and paste it and use it on a number of different parts of the network. And all we need to then do is simply change one part of that expression as opposed to changing all of the channels we're renaming. In addition to this, we can feed any number of channels that we want down into the rename chop running this expression, and they'll all get renamed successfully. So we could have 100 channels. Now if you were to try and enter 100 different entries, space separated manually, this would be a tedious and time consuming task. However, the Python expression is going to completely automate that process. The same expression that works for 6 channels will work for 100 channels, so it's going to really save us a lot of time. So we've got our inverse kin chop. I want to rewire this into a rename chop. And the first thing I want to do is talk a little bit about how the rename chop works. So currently we have our current bone names. If we rename from and enter into to what we want to rename to, a space separated list of text string, if you will, that's going to rename in order from the first channel to the last based on a space separated entry of text. So A, B, C, D, E, and F. And just to prove that it is space separated, I can rename that first one to ABC. And we can see that it is ABC, then B, C, D, as opposed to A, B, C, then B, C, D, etc. So it is space separated. So I'm going to delete that. Let's bring up the expression editor, or actually close that out. Before I do that, I do want to make sure I'm in the Python expression language. Bring up the expression editor. I'm going to shrink this down. Fantastic. Let's set up a very simple Python expression that returns the text star into this 2-parameter. You are going to see that actually this is going to cause a problem for us, and we'll see exactly why in a second. So I'm going to say that we have a return string equal to star, and I want to return that return string. If we apply, what you'll notice is that we've actually set the text and not set the expression. We don't have an expression active here, and we can see that indeed we are editing the string and not editing the expression. What we can do, if we switch over, if we right click and go to expression, toggle expression, and then click apply, We do need to make sure we toggle the expression. There we go. So I actually clicked that once and did it, then activated it from the menu. So if you just toggle the expression once, we're now dealing with an expression. If we then click apply, it's going to set the expression indicated with green. If we close that out, we can now see that if we click on 2, this is the value that we are getting returned from that expression, that star that we were expecting. This is the expression itself. We can now bring up the expression editor on this and see that we're editing the expression and not the string. This is going to be very important to make sure that we are editing the expression when we enter this Python expression and not simply entering that Python expression as the final result. We want to make sure we edit the expression itself. So from there, let's set our return string equal to nothing, so an empty string. And the first thing I want to do is grab all the channels coming into this node. Now to grab all the channels coming into this node, I can reference all the channels in the node above us. And to do that, I can basically grab that node using a relative reference to the node. So we can call on our own node, .node, pass it a relative reference. That will return that node to us, and from there we can grab the channels. However, since we're dealing with a Python expression, we don't need to use the who dot. That's already included for us as a namespace. That means instead of calling on who.pwd, I can simply call on pwd. That's us, the current node that is evaluating this Python expression. .node, that's going to give us a node relative to our node, and I want to grab the node kin underscore l underscore bone 1. So that's going to grab the node that's up inside kinchops / kin underscore l underscore bone 1. And I want to grab his channels. That means I need to call on the .tracks method. That will grab the channels that exist on that particular chop and return them into the channels variable that we just created. So now I can loop through each of those channels, so for channel in channels, and one by one I can work out the name that I want to be used as the new name for that channel, and we can append that into the return string space separated from the previous one. So that means that name by name, space separated argument by space separated argument, we are going to build up this final string that will rename each of our channels. So what I want to do, I want to take the current name and I want to split it based on /, giving us a number of different components. So I'm going to say the split name is equal to channel.name, that's the current name of the channel, .split. I want to split based on /. That means in this case, if we had subnet1 / our bone name : rx, we're going to split that into subnet1 in the is index 0 in the first index, and L underscore bone 1 : rx, or L underscore bone 1 : rz, or even for bone 2 into our second index, into index 1. We can then grab that final index. For example, if we had 3 different parts coming from that split lane, let's say that we had subnet1 / subnet2 / our bone name and the rotate x, that would get split into 3 different entries. We of course want to always grab that final entry, so we want to set our new name to be equal to that final entry. To grab that final entry, we're going to jump inside split name and specify an index. Now the index needs to be the final index of split name. We can work out how many entries there are into split name by calling on len split name. In this case, it would have a result of 2. If it was in our example where we had 3 different components, this would return 3. But we know our index is 0 based. That means I need to subtract 1 from this index in order to actually grab the correct final index, because if we had 2 entries, that means index 0 and 1. 2 minus 1 gives us 1. If we had 3 entries, that means index 0, 1 and 2. 3 minus 1 gives us 2. So we're always going to take that final entry. Once we have that final entry, we can append that into our return string. So let's take our return string and append into it new name, and then of course a space on the end, since we want a space separated list of arguments. From there we can then return the return string once we've looped through all of those channels. If we apply that, we can now see that we are indeed renaming each of those channels, and we are removing the subnet1 / prefix from those channels. If we were to jump up, take subnet1 and collapse that down into a new subnet, subnet2, jump inside and jump inside, we can see still that is working. That's removing all of those prefixes. So that's fantastic. So what I'm going to do, I'm going to Control C to copy that node, and then I'm going to open back up our existing file, discard and open. I want to jump down inside our chop network, and I want to paste that rename chop. So that's pasted successfully. Of course, it's not going to be happy with us because we haven't specified any sources. If we wire this in, it's still not going to be happy with us because we're actually referencing a chop that doesn't exist. But we can bring up our expression. Again, we are editing the expression, not the value. And we can change this now to reference L_arm kinematics. So we're referencing L_arm kinematics. That's going to grab the channels that exist on that chop and rename them. So if we accept, then take a look, we can see that we are renaming all of our channels to the correct names. So now if our channels which do exist inside an asset eventually are going to exist inside an asset, no matter where that asset is placed, we know that we can reference those channels simply by specifying the bone name :RX, RY, RZ, etc. So I'm going to rename this to L_arm kinematics _rename. The final thing I want to do is wire this into a null chop, which I'll rename to L_arm kinematics grab values. The reason I'm using a null chop, I have had a few issues that I've run into with working with referencing chop channel values using the chop expression, the HScript expression, when they're inside an asset. I found that making sure that you reference the chop expression references a null as opposed to any other kind of chop always seems to work. Sometimes with other chops it doesn't always work. So I just found that using a null and referencing a null seems to work all of the time. So I now generally do use a null in order to reference any of my different channel values using the chop HScript expression. So with that is going to conclude this video. We now have those channels renamed no matter where they exist in terms of a network. That means in the next video we can actually look at matching FK over to IK. Thanks a lot, everyone.